Hi there. We're looking at section 5.3, medians and altitudes. So we'll start with medians. A median is a line segment that is drawn from a vertex to the midpoint of the opposite side. So I started here at A, I drew down to the midpoint of side BC. Then I drew one from vertex B over to the midpoint of side AC, and from vertex C over to the midpoint of side AB. The point at which they meet, another point of concurrency, in this case is called the centroid. So the medians all meet at a point called the centroid, which I will write up here. The centroid. That's right here. And the strange thing about the centroid is that it is 2/3 of the distance from the vertex to the midpoint of the opposite side. So, 2/3, 1/3. For example, if the entire length here was 12, then this would be 8 and this would be 4. Notice, of course, because this is 1/3 and this is 2/3, this distance is always going to be half of this distance. So if this is 4, this is 8, the entire thing is 12. 2/3, 1/3. Okay. Taking another example, let's say that you knew that this was a length of 20. So if you did that with so you could just see the answer probably that this is going to have to be 10, and the entire thing then is 30. But if you didn't see that, you could just say 20 is equal to 2/3 of the entire length, x, and then if we multiply by 3/2, both sides, we get 30 equals x, the entire thing, and then 1/3 of that is going to be 10. So we have 20, 10, and the whole thing is 30. All right, those are medians, and the median, by the way, is the balancing point of the triangle. So if you could draw an accurate enough, if you could cut out a triangle and draw a very accurate centroid right here, you could hold the triangle, you could put the triangle on the head of a pin or on the head of, on the point of a pencil, and it would balance perfectly. All right, the altitudes of a triangle. An altitude is drawn from the vertex perpendicular to the opposite side. And it doesn't matter whether it goes through the center or not, but it is going to be perpendicular. And here, and here, and this point is called the orthocenter. So, orthocenter. This point of concurrency is called the orthocenter, and there is actually nothing special about that. It's not equidistant from anything, it's not 2/3 of the distance from anything, it simply exists. But it is a single point. So as with the other three, the perpendicular bisectors, the angle bisectors, and the medians, they meet at a single point, but there's nothing special about it. If you take a look at the median, at the altitudes of a triangle that is not acute, for example, let's see what happens if we take a right triangle, and I make an altitude here, and an altitude here, and an altitude. Let's see, I need to go for this one. Let's see, where do I want to go with this one? That's perpendicular, this is perpendicular, and notice that they are going to meet on the hypotenuse of the triangle. And if I made an acute triangle, let's take this away for a moment, and if I make an acute triangle, the altitudes, in some cases, you are going to have to extend a side in order to get an altitude to a vertex. In this case, I have to extend this side in order to get this altitude perpendicular. All right? And that means I'm going to carry it way down here. And then if I draw this one, and if I draw, let's see, this one, no, that's not going to work. All right, let's try that again.